Today we're going to see about dynamic spectrum access in continuation with CRN applications. So this is just something that a new spectrum sharing that allows the secondary users to access the abundant spectrum pools or white spaces. This is the main application of main content of your cognitive radio networks. Uh, that is, it is a promising technology in order to resolve the spectrum scarcity problem, and it is also increase the spectrum utilization. It overcome two types of interference, that is that harmful interference caused by device malfunction and harmful interference caused by malicious users. So next is something that a secondary users dynamically search for ideal spectrum bands and temporarily access them for wireless communication. To avoid the interference to primary users, secondary users continuously monitor the spectrum bands and yield to the primary user when primary users start using a band. So here the DSA made possible the cognitive radio technology. So these are the function of dynamic spectrum access. That is, one is your spectrum awareness, cognitive processing, and third one is your spectrum access. And next one is your components of cognitive radio. That is, you have an RF front end, that is your analog end. And next is your digital processing engine, and third one is your digital signal processor, and the last one is your customized field programming gateway devices. So next is your DSA model. So DSA model is something that a dynamic exclusive use, an open sharing model, and hierarchical access of model. So dynamic exclusive use is something that the basic structure of current spectrum regulation policy and that are maintained in this model. Here the spectrum band licensed to service for exclusive use, and it improves spectrum efficiency by introducing flexibility. So this is basic structure of your cognitive radio, which supports spectrum property rights, dynamic spectrum allocation and interview, spectrum underlay and spectrum overlay, and exclusive use model and open sharing model and hierarchical access model. These are the modules of dynamic spectrum access. So it has two approaches. One is your spectrum property rights, and second one is your dynamic spectrum allocation. So your spectrum property rights, so here in which it allows the license to sell and trade spectrum to choose technology freely. That is, it is economically profit and plays an important role that it is more profitable use of this limited resources. Next is your dynamic spectrum allocation. It is something that it improves the efficiency through the spectrum assignment by using a spatial and temporal traffic statistics of different services. So next let us see the open sharing model, that is spectrum common models. Every user has equal rights to use a spectrum and applied for wireless services which operates in unlicensed ISM radio bands of wireless LAN. There are three types. One is uncontrolled commons, second one is your managed commons, and third one is your private commons. So overlay of DSA models. So overlay of DFSA model is something that lets you transmit a licensed spectrum band even when a primary user is accessing the band. That is, that secondary user transmits some licensed band even when primary user is accessing the band. This is your overlay of DSA model. Next is your targets maintain a primary user's performance, and secondary users are allowed to transmit simultaneously with respect with along with the primary user as along to no performance degraded. There are two types of approaches are there. One is your channel coding and network coding. So it is used when primary user transmitter is transmitting a primary user packet that is known to the secondary user transmitter. And also secondary user transmitter can split into two parts. That is, one to transmit its own secondary user packet, and also to transmit the primary user packet to enhance the total power received, such as SNIR not degraded. That is said to be your channel coding. Next, let us see about the network coding. Network coding is something that a secondary user relay between disconnected or weakly connected nodes. While receiving the primary user packets, the secondary users may encode and secondary user's packet onto a primary user packet through network coding. So here the transport of the secondary user packet does not include separate spectrum access without degrading a primary performance. This is the main function of the channel coding and network coding. So these are the challenges of your dynamic spectrum access. That is, accurate spectrum sensing is not that much, and uncertainty of noise and PUA attacks are possible in DSA. So if you have any clarification related to this topic, feel free to approach me. Thank you.